All right, Professor Ramani here, and today we're going to have another look at the geometric mean, right? So as your textbook suggests over here, the geometric mean is very useful when it comes to changing percentages, and it has applications in business and economics, and and anything which compounds upon each other, builds upon each other over time. The geometric mean is the way to calculate the average return or average GDP growth over a length of time. So the formula over here is given to you in your textbook. I would like to show another way which I usually write it by. Okay, well, I don't know why it's not showing. Okay, we're back here, and so the way you could think about geometric mean is also 1 plus geometric mean is 1 plus x1, 1 plus x2 for the whole power n. 1 plus x1 plus 1 plus x2, 1 plus x3, all the way to 1 plus xn. So if there are n time periods, where n is the number of time periods. Okay, so the idea is it compounds upon each other. So a quick example to try and see this would be something from your textbook. So here, let's go and work out an exercise problem. So let's do question number 29. Okay, so question number 29 is, so there's a corporation, and over the past 5 years, these were the increases in sales in terms of percentage, right? So in year one, let's try and write this down even more. So year 1, 2, 3, 4, and 5. And in year one, it grew by 9.4%, 13.8, 11.7, 7.9, and 14.7. Okay, so this is how you could create a quick table. And these are the sales growth from the previous years. These are all in percentages, right? And so in order to do if you do a simple arithmetic average, you try and think about it, a simple arithmetic average would be like the average of all these two, right? It will be like 9.4 plus 13.8 plus 11.7 and 14.7. You divide that by 5, and that'll be your arithmetic average. So if you quickly try and work that out, okay, so you have these numbers. Okay, so the average of these numbers would be okay, so that's 12.3. So the arithmetic average over here is 12.3. So, but now you're asked a question where what's the geometric average, right? So the geometric mean. The geometric mean is how historically it has kind of grown over time. And that will be calculated by, let's use the formula over here. So the geometric mean is 1 plus geometric mean. So there are 5 time periods. So this is going to be 1 plus x1 over here, okay? So remember here, these x1, x2s and all these things are in percentages, and this 9.4 is a percentage. So when you're expressing a percentage in decimal form, you need to divide it by 100. So it'll be 0.094. 1, and the second will be 1 plus 0.138, 1 plus 0.117, 1 plus 0.119, and 1 plus 0.147. Okay, so you add these all up. So let's try and divide each of these by 100. Oops. Okay, so these are your decimal of percentages. These are the decimal form of percentages, and so now you need to add like the 1 plus, right? Like, so the cumulative percentage. So you have these cumulative percentages, and then you do multiplication, which is a product. Okay, so that's what you see over here. You're multiplying all of them, and this could be done as a product of all these, and that gives you 1.78. Okay, so now the 1 plus geometric mean whole power 5 is going to be 1.7848. Okay, so back to this, 1 plus geometric mean would be the fifth root, right, of 1.7848, or sometimes you could see it as 1.7848 whole power 1 by 5. And so 1 plus geometric mean would be so that's 1.12. Okay, so that's what we get, and so geometric mean is going to be 0.12285, or represented in percentage forms, 12.285%. This is the average when you try and do a geometric mean, which is 12.285%. Whereas arithmetic mean was 12.3%. The arithmetic mean tends to be a little bit higher over here. Okay, so what is the more accurate way of trying to get the average going backwards when it comes to over time period? The geometric mean is more accurate. Right? Typically in finance or in economics, when you're trying to use a forecast, like, oh, what do you think is the next year's return going to be? The arithmetic mean tends to be used. But whenever you're trying to compute your returns or sales growth in the past, the geometric mean is the way to calculate that. Okay, so try and work out more problems. And if this formula seems, this way of writing the geometric mean seems more intuitive to you, please go ahead and use this. And I honestly find this more straightforward than the way it's shown in your textbook. Okay, like than this format over here. Because it says GM, but implicitly it means 1 plus the small g geometric mean. The same thing, the x1 is given here, but when you see the way, it's like 1.05, and there's like they're kind of explaining it, but I find writing it out in this format helps me. Okay, I'll see you all in the next video.